Calculus, we're working today on the derivative of y equals e to the x. And so yesterday, I'm hoping you made the brilliant discovery that if you have a function e to the x, its derivative is e to the x, which is almost like magic. And so e has that wonderful power. No wonder we have it on our calculators and have ln as well, because they're related to each other. So we're going to just do some e to the x derivatives where it gets more interesting. So if I have f at x equals x squared e to the x, I have some old rules at play that I have a product. So if I want the derivative, I have to remember I've got x squared times e to the x. So I've got the derivative of the first times the second plus the first derivative of the second. That is my derivative. I want to know the value of the derivative at x equals 1. So I have 2e plus another e. And I need a calculator for that. I get approximately 8.15. If f at x equals e to the x squared subtract x, I have an e, but I also have a power. So I've got both of those rules at play. So the derivative of e to the is e to the. But don't forget the guts. So my guts would be 2x subtract 1. We want to know the value of the derivative when x equals 2. So I have e to the 2 overall times 4 to 1 is 3. 3e squared, which again I need my calculator for. The slope of the tangent at that point is approximately 22.167. Okay, next example. We have a product rule again. And we have a chain, sort of, in there in the first part. So I've got 3e to the x squared times 2 to the x. So my derivative would be derivative of the first. Well, the derivative of the first is 3 derivative of e to the is e to the, but don't forget the guts. So I've got that 2x times the second, exactly the way it is, which coincidentally is also 2x, plus the first, exactly the way it is, times the derivative of the second. We could tidy that up a little bit. I see that I have 3e to the x squared everywhere. I'm hesitating because I see a 2 as well. Anyway, I have 4x squared plus 2. Yeah, I could have taken out a common factor of 2, but that's a little bit tidier. Anyway, if I want to know the slope of the tangent when x equals -1, I would have 3e, -1 squared is 1, times 4 times -1 squared is 4, plus 2, which is 6. I need a calculator for that. I get approximately 48.93. Next, I have a quotient rule. So my derivative would be derivative of the top times the bottom, subtract the top derivative of the bottom all over the bottom squared. When x is 2, I would have e squared times 2 squared, which is 4e squared, subtract e squared times 4 again, all over 16, which would give me a slope of 0.